Okay, in this Math 2 video, we're going to do Chapter 2, 81, 83, and 84. For the first one, it says calculate the area of the trapezoid at the right, and then what strategies did you use? So, this is obviously a trapezoid. The formula for the area of a trapezoid would be, area for the trapezoid would be equal to base 1 plus base 2. Multiplied by the height, and all of it divided by 2. So let's see. Base 1, I guess we can say this is base 1. That would be 12, so just substitute it in. Your height, or sorry, base 2 would be this whole thing down here at the bottom, not 18, right? Because 18 is just from here to the edge right there. So let's say 18 plus, what is that, 23, I think? Hopefully. 2 and then 3 more. Yeah, that works. So this is 23. So this is your base 2. Now, the only thing that's missing is your height. So what I'm hoping you notice very quickly is that your height is actually over here. So this whole red thing right there. In order to find that, first you must use the Pythagorean theorem. Here's 5. Here's 13. And here's the height, in order to actually get the height. So you need to do leg squared plus leg squared is equals hypotenuse squared, and you should get a number that is less than 13. Please make sure you get a number that is less than 13 when you find the height. Once you have that, then you can plug it all of them into the formula. 12 plus 23, add that together, multiply by whatever you find for the height, and then divide everything by 2, and then your answer should be in, when you actually find your answer, it should be in feet squared, because these are all feet, and you're finding area, so you have square. Okay, 83. A, B, C, D, E on graph paper, okay, and then use method from problem 2-47 to enlarge it from the origin by a factor of 2, and then label it. And then write the coordinates down, which I'm sure you can do, so I'm going to do the picture first. And then what's the area and perimeter of both figures? Okay, so let's see. We have, okay, we should have enough space. So, okay. Hopefully this goes. I may need bigger graph paper, but I don't think so. Hopefully this will just work out. Let's just hope. I don't want to get another graph paper. Let's see. A is, what's A? -3, 2. -3, -2. Alright, that works out. There's A. There's B. 5, 1, 2, 3, 4, 5, -2. B. C is 5 and 3. D is 1 and 6. Let's see. No, that's D. Sorry, I already have a C. And then E is -3 to 3. Oh, I'm gonna run out of space. Shoot. Okay, I already know I'm gonna run out of space. This is way too big of a figure not to run out of space. Alright, well, we'll do the best that we can, because it's just going to have to end up being off the paper. Alright, most of these, some of these should work. The only one that's going to be off the paper is D. D is definitely going to be off the paper. Okay, so the way that we're going to enlarge this is we're going to count how far away each point is from the center. So we're going to start, does it say, or dilate, enlarge it from the origin? Okay, good. That's fine. So we're going to enlarge it from the origin. So we're going to pretend we're right here, and we're going to shine a flashlight. So our point has to actually be, C prime has to be along this trajectory here. D has to be along this trajectory here, and it's going to end up being off the paper. E is going to end up being along this trajectory here somewhere. A is going to be along this trajectory here. And then B is going to be along this trajectory somewhere over here. Okay, now the question is, where are they? So we need to count. So we are, let's see, 1, 2, 3, 4, 5, 1, 2, 3. So that means we go 1, 2, 3, 4, 5, 1, 2, 3. So that means we're going to end up with C prime somewhere over here. This is going to be our C prime, right? Because we're 5 and 3 up, so we go to another 5 and 3, and that's where C prime is going to be. B is going to be down 2, across 5, down 2, across 1, 2, 1, 2, 3, 4, 5. This is where B prime is going to be. So our trajectory, sorry, I was a little off. Our trajectory is going to be somewhere over there. A is going to be down 2 across 3, down 2 across 3. A is going to be somewhere over here. E is going to be 3 and 3, so 3 and 3. There's E prime. Now, D's off my paper, so, but I'm going to go 1 and 6. So I got to go 1 and 1, 2, 3, 4, 5, 6. So let's say it's probably somewhere up here. D prime. And if you connect the points together, just like we did for the other one, you should get the blown up version of the original, blown up from the origin by a factor of 2. And then you can do this and you can verify also. So let's see, from E to A, right? We're going 1, 2, 3, 4, 5, right? 1, 2, 3, 4. This has a side of 5. 1, 2, 3, 4, 5. This has a side of 5. 1, 2, 3, 4, 5, 6, 7, 8. This is a side of 8. Okay, we need to actually do Pythagorean theorem for this. So what do we have? We have 3 and 4. Okay, so that's 3 squared plus 4 squared equals, so 9 plus 16, that's 25. Okay, so that means this side here is going to be a 5. And this is 3 and 4 also. Okay, so that's going to be another 3, 4, 5. All right, and now we're going to check the, what are we checking? We're going to check the length of this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perfect, because we doubled everything, right? So 8 double should be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, well, it should be the same because they're parallel to each other. And the same length, 5, 5. Now, I'm off the paper with this one, so it's not, I can't really do much counting, but I'm pretty sure it's going to be 10 up here and 10 up here also. But if you're not sure, then you can always do Pythagorean theorem with the triangle that you have here. So what's the distance up here? What's the distance here? Those two are your legs. And then this squared plus that squared should equal this area, this side squared, and take the square root of that. You should end up with 10. All right, perimeter should be easy to do. Perimeter is just what's on the outside. So just add up the information of what's on the outside. Area is going to be done. So we need to split this up because you can't really take the area of this shape. That's not a very good, yeah, it needs to get split up. So I would just break the top part into a triangle up here and then the bottom part into a rectangle. So the area for the green one should be, what is this, 40 inside. That's the area. And then the area for this should be base times height divided by 2 because that's the area of a triangle. Your base is going to be 8 on the triangle. So 8 times, we're going up 3. That's 24 divided by 2 is 12. So the area is 12. For that, the area of this is 40. So the area total should give you 30, no, 30, oh my goodness, I'm counting backwards, subtracting, I don't know why, 52. Okay, so that's the area of the green one, and pretty much do the same thing for perimeter of the green one. Perimeter should be 5 plus 5 plus 5 plus 5. That's 20 plus 8 should give you 28 at least. So area total 52 units squared, right? Perimeter is just 28 units. And then you can do the same thing for the big one that I just did, just perimeter for the outsides, area for the inside. You have a rectangle here and you have a triangle here. Base times height divided by 2. Okay, 84. Determine which of the following triangles must be similar. Justify your answer. And I printed it out with the hints from the CPM website because it should make more sense now. So the hint is find the missing angle measures for each triangle to see if angle-angle similarity actually applies. So the question is, are all the angles the same length, the same measure? Sorry, not the same length. So we have, let's see, 60 and 40, so that makes 100, right? And so that means take away from 180, that gives us 80 here. 60 and 85 gives us, 60 plus 85 gives us 145. 145 take away from 180 gives us 35. Okay, so angles are not the same. So they are not similar. Okay, that takes care of that one. All right, part B, same thing. So you want to make sure that the angles are all the same. If they're all the same, then you should be good to go. If they're not all the same, then it's not good to go. Don't pay attention too much to the sides in this one. Just make sure that the angles are all equal. And you could find that. Should be pretty easy to do. Okay. Part C, it's not really much of an angle thing because you don't have any angles. You don't know what they are. But you could write the ratio for each pair of the sides. So the ratios are going to go the biggest one on the left with the biggest one on the right. The smallest one on the left with the smallest one on the right. The biggest one on the left is 14, right? You cannot pair 14 and 6 together. That wouldn't make any sense. I'm sorry, 16 is the biggest one. Oh my God, I didn't even see that. So you cannot pair 16 and 6 together. You can't pair the largest one on the left with the smallest one on the right. So you're going to pair them up large to large, medium to medium, small to small. So we have 16, right, over 8, 16 over 8. We have, what's the smallest one? 12 and 6, right? 12 and 6. And then in the middle we have 14 and 7. Okay, so 14 and 7. And the question is, are all these ratios the same? Well, you can simplify, right? 16 over 8 just becomes 2 over 1. 12 over 6 becomes 2 over 1. 14 over 7 becomes 2 over 1. So, yes, the ratios are all the same. 2 over 1, 2 over 1, 2 over 1. So that means the triangles are similar because of similar ratios on the sides. Okay? All right, so that takes care of that. Sorry 83 was so long, but it's kind of an involved problem. If you have any questions, please let me know.